System of particles. So basically, let us try to understand the difference between this chapter and previous chapters. So far, in all our chapters, what we assumed was that the object is made up of point mass. Okay, whenever we were saying that a car is moving with velocity of 10 meter per second or 20 meter per second or 50 meter per second, that means we were treating car as a point object. When we were exerting force on any object like a block, okay, and we were calculating A is equal to F by M, we were calculating A is equal to F by M, we were treating the block as a point mass. We were treating block as a point mass, right? But in reality, let me tell you, things are not point masses. In reality, in our day-to-day life, objects are not point masses. Okay, so whatever we have studied so far is useful, but we need to use it, we need to learn how to use that information in our day-to-day life. So basic importance of this chapter is that this chapter bring us closer to the reality. This chapter bring us closer to the reality. And what is close to reality? The point which is noted is that the objects are not point masses. Objects are not point masses, they are bigger objects, okay, and that those objects are basically made up of large number of particles. Those objects are basically made up of large number of particles. That's why this chapter is called system of particles. Okay, an extended object, let me tell you, suppose it is a block. So that block can be treated as to be made up of very large number of particles like this. Okay, the number is very large. I am just trying to make you understand that how things happen. Okay, like this, like this. Okay, so now when you are exerting force on this object F, not every particle is going to move with A is equal to F by M. Not every particle is going to move with A is equal to F by M, which we were easily applying considering it as a point mass. Which we were easily applying considering it as a point mass, right? So, how to study this? How to take care of this? That we are going to study in this chapter. Alright. We are also going to study a few other things related to large number of particles. Now, in this example which I have drawn, okay, I considered this as one object. So basically, there is a block, and within that block all particles are there. Okay, but there is a possibility that in reality, basically, there could be different particles at different places. There could be, let's say, 5 particles I have taken, A, B, C, D, E. So if these 5 particles are there and you are trying to apply force on any of this particle or multiple particles, then how these particles will move? Okay, so all that we are going to study and understand in this chapter, which is called system of particles. So basically, now we have get rid of one point or point mass, and now we are going towards a group of point masses. Okay, those group of point masses can be together, that makes one big object. Those group of I don't understand. Those group of point masses can be different also. Those group of point masses can be separate also basically. Okay. So let us talk further. So first and foremost thing which we study in this chapter is center of mass. Center of mass. Okay. Again, what is importance of center of mass? What is center of mass? Why to study center of mass? All this we are going to talk here. Okay. Now listen carefully. We have supposed this object, okay, which is a block. You have applied a force F, mass of the block is m, and then you calculated A is equal to F by m. A is equal to F by m. So this is acceleration. Now suppose on this block we have four corners A, B, C, D. Okay. Now in out of these four corners A, B, C, D, are all four moving with acceleration A is equal to F by m, or A is moving with some other acceleration, B is moving with some other acceleration, C is moving with some other acceleration, and D is moving with some other acceleration. So if all four are moving with same acceleration, that means entire body is moving with same acceleration. In that case, we can simply assign A is equal to F by m as the acceleration of body. We can call it as acceleration of body. Why? Because every particle on that body is moving with same acceleration. Are you getting it? So when every particle is moving with same acceleration, then that acceleration can be called as acceleration of the object. Okay. But things will become different if acceleration of A is different than acceleration of B, is different than acceleration of C, and different than acceleration of D. So if all four points on the object are moving with different accelerations, let's say AA, AB, AC, AD. Now if we have calculated A is equal to F by m by using our normal method, then to which particle this acceleration should be assigned? Then to which particle this acceleration should be assigned, which we have calculated using A is equal to F by m. Okay. Now let me tell you, that particle is a very special particle or special point basically on the object, and that point is called center of mass. Okay, that point is called center of mass. So what is the center of mass? Now let me start writing. So center of mass of an object is a very special point for the object. Okay, center of mass of an object is a very special point for the object. Now what is special about this? So center of mass is the point, center of mass is the point at which center of mass of the is the point at which entire mass of the system, entire mass of the system can be assumed to be situated. Now this is very interesting line. We are writing assumed to be situated. We have written assumed to be situated. What is meaning of assumed to be situated? That means in reality it is not there. We are assuming. We are assuming. Who we? we student of physics, we teachers of physics, we the community which is related to physics. Okay, it is important to understand that these are all things which are developed by people who are associated with physics. Okay, if you go and talk to some rickshawala and tell him that do you know there is a center of mass of your rickshaw, he will say pata nahi kya bakwas kar rahe. Okay, so try to understand this is not for everyone. Concept can be utilized by everyone, but to make them understand is not necessary. Okay, so first point is the center of mass is the point at which entire mass of the system can be assumed to be situated. Next point, when external force is applied on the object, when external force is applied on the object slash system. Okay, object can be one object also, object can be multiple points also, multiple particles also. So when external force is applied on object slash system, the motion of center of mass will be exactly similar as if same force would have been applied same force would have been applied on a point mass, on a point object of equal mass. Okay, so basically try to understand whatever your type of system is, if you are applying any external force on the system, then the motion of center of mass of the system, it will be exactly same if you convert that whole system in a point mass and then apply the same force on that point mass. Okay, so then the motion will be exactly same. Let us move further. It is possible that at the location of actual center of mass, or at the location of center of mass, what is actual? It is center of mass. So it is possible that at the location of center of mass there could be no mass actually present. Okay, so basically try to understand meaning of this statement, that it is possible that the point which you are calling as center of mass, actually there is no mass. Let me give you examples also. Suppose you have a ring. So this is a ring, and we all know, I am assuming that you still remember, that the center of mass of ring will be its center. Okay, if it is a uniform ring. Now you can see for this ring that at the location of center of mass, which is the center of the ring, actually there is no mass. Because ring is hollow. Right? So even though the ring is hollow, at the center of mass, basically there is no mass at all. Correct? There is a possibility of that also. Another example, if you take example of Earth and Moon. So this is Earth and this is Moon. Okay. Now their center of mass, that means center of mass of Earth Moon system, it will be somewhere close to Earth and it will be on the line joining Moon and Earth. Okay. So this will be the center of mass of Earth Moon system. So in our Earth Moon system, the center of mass is somewhere between the line joining Earth and Moon. Okay, and it will be closer to the Earth, right? Okay, but if you look closely at the location of center of mass of Earth Moon system, actually there is no mass. Actually, there is no mass. Okay, so this is very important. This is very important that in reality, there are chances, there is possibility that at the actual location of center of mass, there could be no mass. There could be no mass. So don't feel astonished, don't feel amazed, don't feel, what we can say, confused. Sir, you were saying that it is the center of mass. I said yes. But sir, here there is no mass. Okay? There is a possibility. Why? Because try to understand, center of mass is a concept. Let me write this in words. Center of mass, is a concept developed by us. Us means physics related people. So center of mass is a concept developed by us to understand and study motion of objects. Motion of complex objects. Now you may ask, sir, what do you mean by complex objects? Suppose there is a ball. Okay, there is a ball. Now this ball has been thrown. Okay, now this ball is spinning also. If this ball is thrown with, let's say, velocity v naught, and this ball is spinning also with angular velocity omega, now velocity of any point on this ball will be extremely complicated. Motion of any point on this ball will be extremely complicated. Why? Because every moment its direction is changing. Every moment its motion is changing. Okay. So to track each and every particle on this object will be extremely difficult if we go by routine way of studying. Alright. But if we go and sit on the center of mass, what does that mean? If we observe the motion of any particle from center of mass, then motion of those particles will be extremely simple. Why? Because for any point, for any object, if we look from center of mass, then motion of any point will be circular only. Motion of any point will be circular only, right? Now, if you observe the motion from center of mass and then add the motion of center of mass, then things will become easy. Okay, like that. So we'll be talking in detail about all these things. But be very clear. Center of mass is a concept. Center of mass is a concept. Be very clear about this. Let me give you an example related to that. Suppose after studying today's class, you became very excited. As you have so much of keenness towards science and physics, some of your friends, you friends, decided that today is 31st and there can be no other occasion better than this to go and have party, New Year celebration at center of mass of Earth Moon system. Today we have studied center of mass. Let me do the calculation. Some of you did the enthusiastic calculations and found the point where the center of mass of Earth Moon system is by doing calculations, right? Okay, after that, one of you took out his rocket. You all got into that. You did the feeding of coordinates and all everything, and you are all ready with your party material like cold drinks, wafers, this, that, everything. So while you are in the rocket or spaceship, okay, you have so much of what we can say good imaginations about the center of mass of Earth Moon system. It is such a special point for the whole world. Why? Because it is center of mass of Earth Moon system. Two of the most important objects for humans. Earth is also important, Moon is also important. So it is such an important point, right? So you were thinking that there would be malls, there would be so many people, happening party, this, that, and you will have great fun today. ऐसा सब सोच के you are traveling. When you reach there, you found nothing. It is completely blank, vacuum. No person, no, not even a single particle is there. Nothing is there. Utter silence. You are so disappointed. You are so disappointed. Is it? This is the point. Have you checked the coordinates properly? Oh. Now try to understand. As I told you, center of mass is a concept. Neither Earth knows, neither Earth knows that okay, this is the center of mass, nor Moon knows that this is the center of mass. We have developed that concept. We have developed that concept through our brain. Okay, so for us, center of mass exists. Okay, for us, center of mass exists. If you suppose, if you burn all these chapters related to center of mass and you delete all the data from all the computers across the world regarding center of mass, then people will not know that there is something called center of mass. Okay, so center of mass exists due to the people who are doing development based on that. Okay, so it's a concept. It's a concept, but it is a very useful concept. Very useful concept. All right. Very nice. Samarth is saying, आज रात वहां जाना पड़ेगा. Okay, Samarth, Tata. Ronald is saying, even there we'll get someone with their old man and still have to pay toll to them. क्या Ronald? Okay, everyone, pay attention. Now we are going to talk about calculation of center of mass. Calculation of center of mass. Okay. Yeah, Ronald is only worried about his money. Too bad. But if he is throwing the party, then he should be worried. Okay, everyone, come back. So calculation of center of mass. When we are doing calculation of center of mass, we are interested in two types of systems. Basically, we'll be considering two types of systems. Number one, when mass is discretely distributed. When mass is discretely distributed. Discretely means What do you mean by discretely? That means it is distributed in form of small particles. So suppose this is x-axis, this is y-axis, and there would be a z-axis also. There would be a z-axis also. Okay. Now, suppose we have m1, its coordinates are x1, y1. We have m2, x2, y2. We have m3, x3, y3. We have m4, x4, y4, and dot 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 mn, xn, yn. Okay. So how center of mass is calculated? So xcm will be, xcm is x coordinate of center of mass. So xcm will be m1 x1 plus m2 x2 plus m3 x3 plus upon, and you can write plus mn xn, because we are going up to nth particle, upon m1 plus m2 plus mn. So xcm, now you want to write it in a stylish way. So how do you write it like this? So this will be sigma I is equal to 1 to n, that will be mi xi upon sigma I is equal to 1 to n mi. Okay, so when you are writing it like this, you are making it very sophisticated. Okay, but in reality it is same as the thing which we have written just above. Okay, so xcm is equal to sigma I is equal to 1 to n mi xi upon sigma I is equal to 1 to n mi. Okay, good. Similarly we can write ycm. Similarly we can write ycm. So m1 y1 plus m2 y2 plus mn yn upon m1 plus m2 plus mn. Okay, so this is ycm, this is ycm, and similarly can be zcm also. Similarly can be zcm also. All right, I hope you all have noted. Let me give you some questions. Question: this is x coordinate, this is y coordinate, this is m. Now this is a point mass at 0, 0. Then we have 2m at a, 0, and then we have 3m at 0, a. Question is very simple. Find RCM. Okay, number 1. Number 2, XCM. Number 3, YCM. I am giving this question in this way so that you can realize that how XCM and YCM and RCM are connected. Okay, everyone, please pay attention. XCM. XCM will be M1x1 plus M2x2 plus M3x3 upon M1 plus M2 plus M3. Okay, so that was M into 0 plus 2M into A plus 3M into 0 upon M plus 2M plus 3M. So that becomes 2M A upon 6M, and that becomes A by 3. That becomes A by 3. Okay, that is X coordinate. Now Y coordinate. So YCM is equal to M1 Y1 plus M2 Y2 plus M3 Y3 upon M1 plus M2 plus M3. So that becomes M into 0 plus 2M into 0 plus 3M into A upon 6M, and that comes out to be A by 2. Okay, so when you have X coordinate, when you have Y coordinates, then you can get RCM also. RCM will be how much? XCM I cap plus YCM J cap. So XCM was how much? A by 3 I cap plus A by 2 J cap. Answer. Suhas, you are writing AI cap, AJ cap. What is this, Suhas? Keep making mistakes. Samarth, keep making mistakes. Okay. You also, Suhas. And when you have got Suhas X coordinate as 2a by 5, Y coordinate as 2a by 5, how you are getting RCM as AI cap and AJ cap? Are you trying to justify? Hmm? If you have taken it the way you are saying, then it should be 2a by 5 I cap and 2a by 5 J cap. Next question. This is X coordinate, this is Y coordinate, and now we have three particles. 1, 2, 3. Okay, this is M, this side is A, this side is A, this side is A. This is 2M and this is 3M. Question says find RCM. Please find. Samarth is saying 7a by 12 I cap plus. He has just changed the answer. Just changed. Hmm. Okay, everyone, please pay attention. So this first particle, which is at origin, its coordinates are 0, comma 0. The second particle, which is 2m basically, this is at a comma 0. The third particle, let me tell you, it is at a by 2, comma a sine 60. A sine 60 is a root 3 by 2. This was the first step to identify coordinates of each point. Now RCM will be, pay attention, m1 into r1 vector plus m2 into r2 vector plus m3 into r3 vector upon m1 plus m2 plus m3. Okay, so what we can do, m into r1 vector 0 I cap plus 0 j cap, because it is 0 comma 0, plus m2, it is 2m into ai cap plus 0 j cap plus 3m into a by 2 I cap plus root 3 a by 2 j cap upon 6m. So this is anyway 0. So what we have got is 2ma plus 3ma by 2 upon 6 I cap plus 3 root 3 MA by 12, right? J cap. I hope I have not made any mistake. Upon M is also there. M is also there. Now what we need to do, we need to cancel. So M, 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 M. Now 2 plus 3 by 2 is 7 by 12. So 7 by 12 A I cap plus 3 times it will be 4. So root 3 A by 4 J cap, and that is your RCM. I hope you also noticed that how conveniently and easily we shifted from coordinates to vectors and vectors to coordinates. Correct? When the coordinates were given to us, how easily we converted those coordinates into vectors and vectors into coordinates. Okay. You also notice that when distances were given, how easily we converted those distances into coordinates. Correct? These are the things which we need to learn to be excellent in exam. Right? Let us move further. Question. This question says there are two masses. This is M1, this is M2, and the separation between them is R. Question says find distance of center of mass of system from M1. Find distance of center of mass of system from M1. Please find. Everyone, please pay attention. First of all, These are the two masses only. So center of mass, please write a star point. Center of mass of a two mass system will lie on the line joining two masses. Okay. So this is very important. Why? Because by using this, we are not even bothered about y coordinate. We can simply find x coordinate and that is sufficient. So this point we are calling 0, 0. Other point we can call at r, 0, and we can simply coordinate or we can simply find x coordinate. So xcm will be m1 x1 plus m2 x2 upon m1 plus m2. So xcm will be m2r upon m1 plus m2. Okay. Now pay attention. Suppose this is our center of mass. So this distance is m2r upon m1 plus m2, and this distance will be m1r upon m1 plus m2. Okay, remember that. Okay, if distance is calculated from m1, it is m2r upon m1 plus m2. If distance is to be calculated from m2, then it will be m1r upon m1 plus m2. Then it will be m1r upon m1 plus m2. Okay, good. Next point. So this is how we calculate center of mass when mass is discretely distributed. What do you mean by discretely distributed? When mass is distributed in form of several point masses. Case 2. When mass is continuously distributed. When mass is continuously distributed. Okay. So what happens when mass is continuously distributed? So suppose this is an object of any shape. Now how you are, no, it's not like this. Yeah, how you are saying that it is continuous distribution? Because you can see that there is no break. Break in the sense there are no two particles, there is only one particle or one object, and which is one uniform solid object. The shape can be anything. So here we are calling this as x-axis, this as y-axis, and this as z-axis. Okay. Now, how to calculate center of mass of such object? So method is very simple. We are going to consider a small element. Okay. This element will have certain position vectors. Let me call it r vector. Mass of this element is dm. Okay. So RCM vector will be integration RDM upon integration dm. This will be your method. So basically, if you observe, your sigma sign has been changed into integration. This also tells you how integration and sigma are different. Sigma is to be used when you have multiple things. Okay, thing number 1, number 2, number 3, number 4, number 5. So when you are going and finding value from each one, then it is sigma. But when you have an object which is extended, there is no break, it is continuous thing, then the same sigma gets converted into integration. And that same sigma, because sigma is also summation, integration is repetitive summation. What is required for integration? There should be no break. So here there is no break. Correct? Okay. Now suppose if you want to know, sir, we are interested only in XCM. I said okay. So XCM will be integration XTM upon integration DM. Similarly, YCM will be YDM upon integration DM, and so on. Okay, good. Now let us see some questions so that you can learn how to use these concepts. Question. This is a rod ML, uniform rod. ML uniform rod. This end is A, this end is B. Find center of mass of uniform rod. Please find. Everyone, please find. Okay. Now in this case, pay attention. As the entire mass of rod is along x-axis, its center of mass will lie on x-axis. Okay. This is 0 and this is L. So I am writing this as entire mass of rod lie on x-axis, its center of mass will fall on x-axis. Okay. Excuse me. Just by writing this line, you have ensured that you don't need to calculate YCM and ZCM. Okay. Just by writing this line, you have ensured that you don't need to write YCM and ZCM. Okay. Now let us move further. What we need to do is we need to find X coordinate. Okay. But the problem which we are facing is that this is not a point mass. It is an extended mass. So what we are going to do, we are going at a distance x and taking an element of length dx. We are also assuming that its mass is dm. Okay. So dm will be nothing but mass per unit length, which is m by l, into length of this element dx. So this is the value of dm. This is the value of dm. Now xcm will be integration x dm upon integration dm. Okay. So that will come out to be x is x, dm is m by l dx upon integration dm. Integration dm means total mass of the rod, which is m. Okay, so m got cancelled. Okay, what will be the limits? So the first element you are getting at here, which is x is equal to 0. The last element you will be getting here, which is x is equal to l, because entire rod is between 0 to l. So before 0 there is no rod, after 0 there will be no rod. So limit is from 0 to l. It is important to identify that how limits are to be decided. How limits are to be decided. Okay. So now it is very simple. XCM will be integration x dx will be x square by 2 and limit is from 0 to l. That will be and m by l. So 1 upon l is also there. Just a second. 1 upon l is also there. So when you solve, this comes out to be l by 2 answer. Please note. Okay. Any doubt, any question, anyone? Any doubt, any question? Okay, good. Okay. Next question. There is a half ring ML. Mass of half ring is m and l is the length. Okay. And this is x-axis. This is y-axis. Question says find, rather than ml, put it mr. R is the radius of ring. And let me write half ring. Question says find coordinates of center of mass of half ring. Please find. Samarth is saying y CM is equal to 2r upon pi. What is XCM, Samarth? Okay, everyone, please pay attention. Please pay attention. And the first thing which you should remember and note that for any object, its center of mass lies on its axis of symmetry. Okay, star point. For any object, its center of mass lies on its axis of symmetry. Axis of symmetry. Everyone, please pay attention. If you see the object with respect to y-axis. Okay. So the portion which is on left side and the portion which is on right side is exactly the mirror image. Exactly same. Yes or no? If you observe with respect to y-axis, the world which is in left side and the world which is on right side is exactly the same. Okay. So what we can see here, that as the half ring is symmetric about y-axis, its center of mass will lie on y-axis. Okay. So we are going to use this to find our answer. So as the half ring is symmetric about as the half ring is symmetric about y-axis, its center of mass will lie on okay y-axis. Now keep this thing in mind that you can use these statements to reach to your answer. Okay. Now by writing this statement, we have ensured that we don't need to calculate xcm. So we can simply write xcm is equal to 0 because this point is 0. Okay. So xcm will be 0. xcm will be 0. Okay. All right. Let us move further. Now what we are doing to calculate the center of mass. So we are going at an angle theta. We are going at an angle theta and taking an element of angle d theta. So basically what type of element we are taking? We are taking angular element. Okay. In previous question of rod, we took linear element. Here we are taking angular element. So once again I am telling you, we have gone at an angle theta and taken an element of angle d theta. So if dm is mass of the element, okay, then ycm will be integration y dm upon integration dm. Okay. Now what is y here? Y is the y coordinate of element, and that y coordinate is nothing but r sin theta. Correct? Y coordinate is nothing but r sin theta because r is the radius of ring. Okay, so what we can write here is integration r sin theta. Now the next question is how much is dm? So pay attention everyone. See, when we are taking angular elements, the maximum we can rotate is pi. The maximum we can rotate is pi. So in pi angle mass is capital M. In pi angle mass is capital M. So in unit angle mass will be m upon pi. In unit angle mass will be m upon pi. So in d theta angle mass will be dm, and that will be m upon pi into d theta. Okay, so our dm comes out to be m upon pi d theta. Now you tell me what will be the value of integration dm? Integration dm is total mass of the ring, and total mass of the half ring is given as m. So let us cancel m. So m got cancelled. Okay, one more thing. What will be your limits? So you are starting when theta is 0 degree and you are ending when theta is pi. So your limits will be from 0 to pi. So r upon pi, these are constants, so it can be taken out of integration and we are left with sine theta d theta, and limit is from 0 to pi. Okay, so r upon pi, integration sine theta d theta will be minus cos theta, and limit is from 0 to pi. So when you are going to solve all that, you will be getting 2r upon pi. Remember that, everyone. Okay, it's an important data related to such questions. Okay, so YCM is 2r upon pi. Please note. Noted? Good. Now, next question. This time, you have a half disk M R. Okay, this is x-axis, this is y-axis. Question says the same thing. Find coordinates of center of mass of half disk. Okay, please start. In the meantime, I am filling the Mhm. You don't need to fill it. I have time. That's why I am doing this. Okay, you need to solve the question. Hmm. Have you given answer based on calculation or based on memory? Okay, everyone, please pay attention. So in this question, as mass is in the entire disk, what I am doing, I am going at height y and considering a ring. Okay, let me take it as h. So we are going at height h and taking a ring. Our element is ring. Okay, so this is the ring which we have taken. Suppose dm is mass of this ring. So again ycm will be integration y dm upon integration dm. Okay, what is y here? Y here is coordinate of center of mass of element taken, chosen basically. Our element is what? Ring. So its ycm will be 2h upon pi because we have just done that. So that will be integration 2h upon pi into, now comes dm. How much is dm? Let us find that. Okay, so pay attention everyone. In area pi r square by 2, mass was capital M, correct? So in unit area, mass will be 2m upon pi r square. So in dA area, mass will be dm is equal to twice m upon pi r square into dA. Okay, so let me put that 2m upon pi r square into dA. Now integration dm, which is in the denominator, that will be capital M. Okay, so this m and this m got cancelled. Now those constant things can be taken out. So 4 is taken out. Pi into pi r square is taken out. And what is left inside is h dA. Okay. Now pay attention everyone. The thickness of this is dh. The thickness of ring is dh. So dA, that means area of this ring, will be its length into width, which is dh. Now how much is length of ring? Basically it is circumference. So it will be pi h, because pi r is half ring's length, circumference, and dh is anyway dh. So this is the value of dA. So let us put that. So this will be 4 upon pi into pi r square into integration. H is already there and dA is pi h dh. So 1 pi will get cancelled. Okay. So now what we are left with, 4 upon pi r square integration h square dh, and limit will be from 0 to r. So this is ycm. So ycm comes out to be 4 upon pi r square. This will be h cube by 3 and limit is from 0 to r. So that will give us finally ycm is equal to 4r upon 3 pi. I want all of you to do this derivation once again after the class. Okay. Answer will be 4r upon 3 pi. The purpose of making you write this question once again is to tell you the process. Okay. To make you go through the process of how things happen. Okay. How elements are taken. How you think in a question. This is going to help you in many other questions. Okay. Nobody is going to ask you this derivation in exam. Be very clear about this. But this understanding of how each and every step is taken, how you fetch data from things which are given to you for the question. This is very important, which you need to learn. Okay, so it is my suggestion that you all should attempt this question once again after the class, and by doing all the steps, by following all the steps with full attention. You should be knowing, okay, how I am doing this, why I am doing this, and how these steps are to be taken. Okay, that is enough for today. We'll meet in the new year. Okay then, bye bye everyone.